G'day, it's Adam VK4GHZ. If somebody tells you a Meanwell switch mode power supply is low noise and really good for the ham radio environment, you can tell them they're full of shit. In this 3-rack unit enclosure, I have a Meanwell HRP 300-12. That's a 300 watt, 12 volt nominal switch mode supply. I purchased this back in June 23 from Mouser Electronics for 168 bucks. It's actually adjustable from 10.9 to 14.6 volts. It's got 27 amp capability. Seems perfect, right? So I'm trying to get reinterested in the ham radio hobby again and get back on air. But you know, the noise this Meanwell power switch mode supply generates is just, excuse the French, f***ing disgusting. So, whereabouts on the spectrum is this noise and can it be fixed? Now, quick backstory on this power supply project. It was originally based on the VK PowerMate 25, which was in EA, Electronics Australia, January 1990. It had two mains transformers and 2 full-wave bridge rectifiers paralleled up to provide the current of 25 amps. Then it fed a bank of 6 10,000 microfarad electrolytics. Went off into an LM723 voltage regulator, and there was half a dozen 2N3055 series pass transistors. Nothing particularly unique at the time, and the transformers I was using was 2 of these toroidals. They were 18 volt secondaries and 8.3 amps each, so there was a pair of those per transformer. So we'll call that 16 amps by 2. I had 32 amps of capacity in the transformers. This is the LM723 regulator board. It just bolted down to the cross rails inside the enclosure. The electrolytic capacitor was just a single unit, 61,000 microfarads. That could have been part of the problem, actually. The 2N3055 series pass transistors on heat sinks, and there was a muffin fan here. It was built like a tank. The problem with it was, though, every now and then, every couple of years, it would blow one of the 35 amp bridge rectifiers. And that was a real pain in the ass to fix, because you'd have to get in there, open the thing up, get in there, desolder all the wires off the bridge, and put using your multimeter to test all the diodes to see which bridge was faulty. Not expensive, they're only $9 to replace, but just a complete pain in the ass all the same. And this happened to others as well. I found a blog entry by VK3ZPF who describes the same thing, a bridge rectifier shitting itself. So in a moment of insanity, I decided to pull all this linear crap out and replace it with a Meanwell supply. I mean, after trawling some forums and seeing what other people were saying about them, they seem to have a pretty good reputation. They're probably one of the better ones that are made in China. It's got everything you could possibly want. It's got over voltage protection, over temperature protection, overload protection, current limiting. So it sounds pretty good, right? As soon as I finished wiring this up and making it pretty, I've even put some Andersons on the back. Welcome to 2012, I know. And then the 50 amp Andersons there. As soon as I hooked up the IC7600, I knew that was a big mistake. The noise across most of the HF bands was just terrible. So what I'm going to do today is we'll have a sniff around, we'll have a look at it on the spectrum analyzer, see where the noise is, and see if there's anything we can do about this, because at the moment, as it is, it's just unusable. There's 2 types of noise we're interested in: conducted, that is noise that's traveling up your DC power cable, and radiated. Radiated noise is transmitted through the air just like any other radio signal. So for this experiment, I'm going to power the IC7600 off my kick-ass lithium phosphate power station. Being a battery, we can consider it to be nice, clean power. Here is my my sense antenna. It's just simply a short RG58 coax patch lead with an alligator clip lead as the sense antenna. So I'm just going to put that there. I'm going to turn the disgusto box on. Have a look at that. That's terrible. So I'm going to tune around the main handband. In fact, let's just tune all the way down. So starting at 30 megahertz. Now notice that. You'll see we've switched from the general coverage filters to the handband specific filters when we go into the 10 meter band. So I'm just going to go to AM just to speed up the tuning rate. .15 meter band. It's terrible. Down to 20 meters. .40 meters. Just to show you, I'll turn this off. Back on again. .80 meters. So pretty grotty. Now let's go above 30 megs. It's really bad up here. .6 meters. I mean, and so forth. I mean, yeah, that's... All right, so that's just listening to it on a handbox. Let's take a look at the spectrum analyzer, see what we can see. Again, I've got a simple coax patch lead with a clip lead acting as a sniffing antenna. I'm just going to put it there. Actually, we get more noise just if it's near the DC leads. I've got the HP spec AN hooked up to the PC via a GPIB interface, and I'm just going to do a capturing the data now. Just to explain what we're looking for, I'm starting this at DC, and the stop frequency is 60 megahertz. We have 10 horizontal divisions, so each horizontal division is 6 megahertz wide. So working from the left, 0 there, 6, 12, 18, 24, 30. As we saw, it was pretty bad. Down at 30 megahertz, look at that. You can see the signal strength come way up. 30, 36. So that was all, it was really, that's where it is the worst there, between 30 and 36. Starts to fall down a little bit by 42, 48, 54, 60 megahertz. So peak concentration, what do we say, 6, 12, 18, 24. Let's call that 28, 30, 36, 42, 48. It's pretty much 28 to 48 megahertz. It's the worst. It's being powered off the lithium phosphate battery. You can see we're sitting at about some nearby activity. We'll just tune away from that. 28,490. So we're sitting at about strength 5 on the S meter. Let's plug this off the Meanwell. So strength 5 on the battery. Look at that, 10/9. I think that's pretty shit, don't you? Let's go to 20 meters. Strength 9. Let's. So this is noise. Oh, hello. This is noise coming up the DC power lead. All the difference you're seeing is the noise coming up the DC power lead. Right, back onto the lithium phosphate battery. Instant reduction in noise. So what can we do about that? Well, one thing I'm hoping is going to fix the problem. I bought this months ago, actually. It's been sitting here. Massive backlog of projects. This is a filter, a 50 amp, 2-stage DC line filter. Got this from VK Amps. So what I'm going to do, I'm going to mount it to an aluminium plate, and we will bolt this into the power supply. I'll reroute the DC cable coming out of the Meanwell and feed it into this, and out the output will go to all the sockets. Let's see how we go with that. A couple of days later and a haircut later, let's have a look to see what I've done here. I've mounted the filter board on some 1mm aluminium sheet as a backing plate. One aspect of this filter board I don't really like is the connectivity. If it were my PCB, I would have had M4 plated through holes on the in and out pads, so you had the option of bolting solder lugs to them. Because we can't do that, we need to be careful about strain relief so we don't pull the pads off the PCB accidentally. I used some 5mm mains flex cable clamps by removing the nails and drilling out the holes to take M3 hardware so the clamps could be bolted onto the aluminium backing plate as well. 2 layers of PVC tape were placed down at either end, just going under the PCB slightly. With all of that, it was bolted into the enclosure and soldered up. Let's do a conducted noise test now. I've still got the 7600 running off the lithium phosphate battery. We can see that we're sitting at about an S6 noise floor. This is running off on a 6 meter vertical antenna. Let's call that S6. Let's swap over to the Meanwell supply to see if we notice any increase in noise. It's on 13.85 volts. Strength 6 noise floor. So I can't really hear or see any noise increase like I could before. And just looking at the Spectrum Lab audio scope, I can't see anything nasty in the waterfall display either. Just go to 10 meters. Yep. Bit of activity there. Let's just tune away from that. Try and find somewhere clear. So we've got a strength 4 to 5 noise floor there. Just swap over to the lithium phosphate battery. That is strength 4. It's interesting. It's a little bit 3 to 4. Okay. Let's go back again. Just to remember, the peak noise was at between 28 and 38, wasn't it? Strength. Oh, 3 to 4. It'd be nice to have an AB switch just to quickly switch between it. But all right, that's under 4. 3 to 4. One more time. Let's go back to the lithium phosphate battery. Between 3 and 4. I can't really see any or hear any much of a difference, if at all. This is hardly scientific by any means. All right, let's turn the Handtech DSO on and let's see what we can see. So on the input side of the filter, we're seeing these noise spikes, and I've measured these at 15.4 microseconds. That correlates to 65 kilohertz, and the switching frequency of the Meanwell is nominally 70 kilohertz, so that explains what they are. They're peaking at about, what do I see there, 200 millivolts. 240. Saw 240 millivolts peak to peak. Let's move that to the output side now. 171 millivolts I saw. So there is a reduction there. But most importantly, we can't hear it on the bloody receiver. So that at the end of the day, you can make all the measurements you like, but if you can't see or hear it on your receiver, you're looking good. Anyway, what have we learned here? One, stick to a linear supply if you can. I just got jack of the fact that I was replacing the 35 amp bridge rectifiers. I've done that several times now, and the power supply was built in the 90s. I thought maybe it's time for a change. Secondly, don't believe everything you hear about Meanwell power supplies being clean, because obviously they're not. This thing's, fucking disgusting, and luckily this DC filter fixed that up. Anyway, after 30 odd years, I thought maybe it was time for a change, so that's why I ripped all the linear stuff out and got the Meanwell power supply. Needless to say, it's absolutely unusable without some sort of LC filter. This does the job, but when you add up all the costs, like that was $168, the filter was $99 plus shipping, you're looking at around $300. Then of course, if you're doing it yourself, you've got the cost of the enclosure, the connectors, the switch, blah, 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 blah. It goes on and on and on. So you can easily spend $500-600. You can buy yourself a pretty nice linear power supply for that. So if I had my time again, I would just stick to a nice linear supply. Forget about switch mount supplies, unless you know they are definitely clean, because these Meanwells are not. Anyway, thanks for watching. See you next time.
Boo! Boo! That was the worst thing I ever heard. It was terrible. Horrendous. Well, it wasn't that bad. Oh, yeah? Oh, there were parts of it I liked. Yeah, I liked a lot of it. Yeah, it was good. It was great. It's wonderful. Oh, bravo. More!
Now can I say it?
Yep.
Go away!
Scram!
Get out of here!
Get out of here! Skedaddle! Go away!
Ham's gray!
Well, come on.
All right.